I have been in the industry for 2.5 years and I work as a Java developer for 10
Hey,
minutes.
Meenu, I'm having a little trouble understanding what you're saying. Your voice is breaking.
Yeah.
Is it better now?
Minu's voice is not clear, I
Hello?
think.
Hello?
Hello?
Hello? Am I audible?
Yeah, I
You're
think now it's
Not loud.
audible.
Yeah, you're audible, but I think it just cuts off. Yeah, so I think you can just try continue speaking, but yeah.
Let me know whenever the voice breaks.
Mhm.
Yeah.
I think there
so,
is a lot of background disturbance comes with whenever you speak. I'm not sure if it is coming from mic or something else.
Maybe my mic has a problem. So I have been in the industry for 3.5 years and I work as a Java developer. Namita, you can introduce yourself.
Sure. Hi, everyone. I'm Namita. I have been a software developer for 6+ years, more than that, actually, 8+ years now, and just haven't been interviewing for last 6 years. So just trying to get back into the interviewing mode and trying to prepare. So really looking forward to this. And thank you so much, Meenu, and thank you everyone on SDE Skills for this platform.
Am I still audible?
Yeah, Meenu, you're audible, just that it feels like your voice is coming from the background. So if you are like on speaker or something, if you can use headphones, that might probably make it better. Not sure.
Give me a second. I'll just check with them. But till then, we can discuss on the first question if you don't mind.
Sure, yeah, sounds good.
Yeah. So let's say we are given the root node of two uh, binary search trees,
Mm-hmm.
and you're given a target value.
Mm-hmm.
And I want you to find me a pair to return me a Boolean value to see if a pair of numbers are present in these binary search trees, which adds up to the target.
Sorry, can you say that again? The pair of values?
Pair of nodes whose values adds up to the target value.
Okay, so the pair of nodes in the same tree, or like pair of nodes
Different
from
trees,
different trees?
from two
That
different trees.
got it. So basically there are like two binary search trees, and like the root nodes of both of them are given, and we want to find if there is a pair of nodes from two different, like one in the pair there is like an A and a B, then A should be in the first tree, and the
Hey Namita, sorry to interrupt. Can you increase the font of your pad and then can you drag it up a little bit? His font is very small. Yeah.
is this better?
Yeah, it's fine.
Okay. Yeah, so sorry, I was saying that A should be like the first from the first BST, and the B should be from the second BST.
Right, right.
Okay. And it should be just like a boolean. You want to return a boolean if I
Yeah.
find. Okay. Cool. So I'm just trying to see what the method would look like. And So I'm just assuming like a
And-
tree
and
node
you're
kind of a
also-
structure.
And also you're given an integer value.
Oh yes, yeah. Yeah, I'm just going to assume that we are given like a tree node, and the tree node would have like a value and a left and a right child.
Right.
Sorry, not. Okay. So basically the way that I'm thinking right now is because we have a target, I'm just gonna iterate through each of the tree nodes and going to try to find if the diff of the target. So I'm going to iterate on the first tree, and with each value, I'm going to see what is the diff. And with that diff, I'm trying to find that diff in the other node, other tree. So that's like the first thing that comes to my mind with this question. And yeah, so yeah, for the first tree, I'm just going to iterate the entire tree, and then in the second tree, I'm just going to try to find a diff. Does that sound like a good approach to you?
Oh, that's good. So for every root one, sorry, on the nodes in root one, you're going to traverse the entire tree for every node in root one.
Yes, for
Something
the
like that.
yes. So the way that I'm thinking about this is like iterate the first tree, and like for each like value that I find in the first tree,
Mm-hmm.
I'm just going to figure out like what is my diff. Sorry. Then I'm just going to find like target minus that particular value, that would be my diff, and I'm going to iterate the second tree like using the binary search tree property to see like if I can find that particular value here or not. So,
Okay, so what would be the time complexity in case we do that?
the time complexity would be like we will have to iterate O of n for the first tree. So O of n, and for each node, I'm going to try to look it up in the other tree. So it would be like log n for each of that node. So it would be n log n.
Can be better.
Sorry, I think you
Yeah.
got.
Can be better that.
Can we better that? Yeah, I'm thinking. Mm. Yeah, I'm just trying to see like how can we
Sure.
avoid using avoid iterating the first tree node
So
to
for the
find the
second
diff.
tree node, we are going to traverse the entire tree node. So will that not make sense if we have it saved up somewhere and we just look it up?
Yeah, I mean we can basically put it in a map and then try to look it up from a map, like one of the trees, and then we can just iterate one tree. That's another possibility. Like we just iterate the second tree and store it in a map. And then just look up the map. So that's gonna save like the log n time complexity that we are doing. And it can make it n log n, but we'll have additional space of n,
Right.
order of n. Does that sound like a good approach?
Uh, so we'll be saving that whatever nodes we are traversing, we'll be saving that up in an array list or something. Are you
No, we
trying
will be
to
storing it in a
use?
map, right?
No,
So,
for root one. Here we are not
no,
saying
I'm saying that we iterate root one just like that, and then we try to find the diff from the root two.
okay.
So I would
But,
still do like O of n in this tree, first tree.
can we use up some property of binary search tree to make the solution a bit better?
Mm. Yeah, I think, yeah, then yeah, I think you're right. So what we can do is maybe then from the root, but we will still have to do like an O of n comparison, like O of n loop, right? So the first O of n loop would be I make the tree to a map. So that's one thing. And like if I iterate through my map and try to find the diff in the tree node 1, that's going to make it log n. But this will still be like
Right.
O of n iteration from the map. So that's why I thought that the other approach would be better, because this is still again making it O of n log n. If I traverse from every entry in the map, then just I'm not sure like what.
Sounds about right.
So basically we will just, yeah, I am not able to think of anything else that's going to make it less than O of n without a space, like without adding space.
Okay, so if we add up space, will our solution be better time-wise? Let's take for example, let's take for now we do not have any constraint on the space. Can we make our solution more efficient in terms of time if space is not the issue?
Mm. Yeah, I'm thinking we have already added like a map here for the second tree, and
Mhm. Okay, never mind. We can go ahead with this code if that's okay.
okay, yeah, I am not really able to think to make it less than O of n.
Sure, no problem. Go ahead. You can code it out.
Okay. Yeah, so the first thing is like I'm going to make it to a map, like so. So I'll implement this later. I'm just assuming that I have a method that is basically storing everything from this tree to map. I'll implement that later. And another method that I have is so I'm just going to pass this map and also the root one. And this would be like a recursive function that is going to return this.
Okay. Hey Namita, one question.
Mhm.
So does anything change because we mentioned here we'd be using binary search tree? Will that make any difference if we are using normal tree and if we are using binary search tree? Will anything differ in your approach?
Not in my approach actually, because I'm iterating through this tree entirely.
So can we use some BST property to make the solution a bit better? Can you think of something? Like what are the properties of BST and how that can be used in our problem?
Mm. Yeah, so basically binary search tree, we can be if we are trying to find a target value or like a diff, we can basically try to do that in O of log n property. But for that we used up a map here. And mm,
Both the trees are BSTs. So can we use the property in both the trees?
yeah, so I mean, I get it that we should use it, but I'm just like blanking out right now on how
Uh, we can
would we
start
use
with,
it.
so what are the, how can we traverse a BST which can give you, let's say you're given two arrays.
Mm-hmm.
Is there any possibility, how do we find, let's say you're given one array and you have to find pair of numbers which add up to a target value.
Mm-hmm.
How would you do that?
If I'm given an array and I have to find a target number, I would still do similar approach where I put everything from the array into a map, and then I would traverse that array and try to find the diff into the map. That's like a similar approach on what I'm trying to do right now.
So does anything change if the array is sorted? If
Uh,
you're, if the array is sorted and you're asked to find a pair of numbers which adds up to a certain number, will anything change?
I yes, I think so. We can basically stop iterating if the diff is coming up to like a, so yeah, so basically if we have like 1 2 3 4 5 as numbers in the array, and we have to find like a target sum as 7 and 5. So once we are trying to find a 4, so then we basically try to look it up using like a BST or like a sorted property, that we have to go into the right side of the array versus the left side of the array. But yeah,
Can you think of something where we are not using map and like if we want to find six, we know the maximum sum which we can get is 1 and 5. So
yeah,
and
yeah. Mhm.
minimum sum we can get is 1 and 2. So can we take that information into consideration and think where we are not using map?
Yeah, let me try to see, like maximum sum can be 6 and minimum sum can be
1 and 2.
3.
Yes.
Yeah.
So can we use same kind of information to find our solution, pair exists or not?
Yeah, and like target is 5 and maximum sum is 6, minimum sum is 3. So this gives us one
So let's say you
information.
have
Mhm.
starred and end pointers and you find the sum and you can squeeze the window as per required start and end pointers.
Yeah. Okay. Yeah. So basically what we can do is, yeah, I think thank you so much on this. We can basically try to see that if this is my start pointer and this is like the end pointer that we are having, and the target sum is 5, this is making it a 6. So we basically decrement the end pointer and
Right.
increment the start pointer, because that's something that's going to give us maybe yeah
Right.
yeah. So maybe this would do. I'm just trying to iterate through it to see like if this is really
Sure.
something that's going to be helpful for us. So then we iterate the start, and then this is again a 6. It is still greater than the target sum. So then we keep incrementing the start and decrementing. But not really. At that point, then we only have to decrement the end pointer to get to our solution here.
Right.
So at that time, when I'm here, I will have to see if I want to do only one decrement, and I keep this here. So at that time, what I can do is I can see what is the diff between my target and like my one element that is and minus minus, and one element that is like greater than start, and then we can decide using that. So when I'm at a 4 and 2 and I still have 5 to reach to, at that time and my start is at 2 and end is at 4. So at that time I see if like my target sum
1 and
versus
4 is going to give you the target sum, right? So when 1 plus 5 is exceeding our target, we can just decrement the end pointer, and then start and end would give me the correct value. So you do not have
Yeah.
to move both the pointers at the same time. We can check for the condition and then squeeze our window.
Yes, that is
Right.
correct.
So can we use that information for our actual problem?
Yes, I think so, because so in the first tree we start iterating, and then in the second tree
So which
we
property
iterate.
exactly we are going to use here? Which property of binary search tree we are going to use here?
We are basically going to use that the trees like can be at traversed like in, because they are
Right.
sorted and they can be like traversed either like every time, either you go left and then make the problem statement half, and then you go right and another problem statement into half. So that's something that we are trying to do.
So can we keep our pointers at lowest value for tree 1 and highest value for tree 2, because that's going to give you the maximum sum, right? And then
Yes,
keep traversing as per our condition. Can we move up like in order and reverse in order?
yes, I think so. Yeah, that might work. Okay, I think yeah, that might work. So first we will have to travel like go till the last, I mean the maximum node of the second tree, and then the first node of the first
Right.
tree, and then that's how we will start
Right.
incrementing and iterating. Cool. Yeah, I think that sounds good. I'll try to see if we can code it up. I'll just move all of this. I'll keep this and try new.
Sure.
Yeah, so we'll see one method that's going to just give us like the maximum node of the 3, 2.
Okay.
Yeah, so I'm just thinking if I should do this iteratively or recursively, if there is directly a way to for me to go to that maximum route.
We just discussed on that if we are traversing in an in order fashion in the tree, it will give us a sorted array. So
Yeah. Yeah, I mean, in order traversal is fine. I'm just trying to see that at what node this is going to give me like the maximum one. So when I'm at the right most node, that's what I want. I have to keep going till I find the rightmost node.
okay, but I am lost. Sorry. So why are we using this max node?
We are trying to go to the maximum that node where we want to start, right, in the second tree. That's what I'm trying to go to.
So that would be the rightmost tree, rightmost node, right?
Yeah.
So anyways, Nimita, I think time is up for this question. Do you want to go to the next one?
Okay.
Okay. So you're given an string. You're given a string, and I want you to return me the length of longest substring that uh, contains at most 2 distinct characters.
Longest substring that
That contains at most 2 distinct characters.
longest substring that contains 2 distinct characters. Okay, so can you give me an example for this one?
Sure, sure. Let's say you have a string CCAABBB,
Mm-hmm.
and it has to and 2 distinct characters, so the substring would be AABBB.
Got it. Yeah. Okay. So the way that I'm thinking about this is like if I keep going and I try to see like how many characters are there that are consecutively the same, and maybe I try to somehow like
They don't have to be consecutively same.
Mhm.
So
Okay. So it can be like any.
yes. So we just want to a substring which contains 2 distinct characters. For example, let me give you another example. ECEBA.
ECEBA.
Yes. So the longest substring would be ECE.
It would be like everything, right?
2 distinct characters. So
Oh,
we can
it
just
only
say,
needs to have 2.
yes.
Because EBA would also be something that
But
is.
it has 3 distinct characters, right? So we cannot take that.
I see. So it's just ECE. Got it.
And that is at most 2 distinct characters.
Okay. Okay, so I think that the way that I am thinking about this is I start iterating. I try to keep track of how many distinct characters have I found and what is the maximum length that I've found till now. When I get like another repeat character, I break that and then I start like from the next character again. And I'll have like a global maximum length of the 2 distinct character string that I've already found, and then I'll keep iterating. That is something that I'm thinking right now.
Okay. Okay.
So basically, the way like I'll have one loop that would have like the first character that I found, and then inside another loop that I keep iterating. If I find another like no, and it just will be one loop. So I go through like E, and then I would go to and then I'll go to a C. So this is a separate distinct character. So I'll say like, okay, I found another distinct character, and the distinct characters are like 2. At that time, the length of this string would become 2. And then when I go to E again, then at that time I did not, I mean, this is not a distinct character, but something that I've already in the string that I'm looking at. So it will be 2 only. And then I get a B. So if I add a B to the already existing string, then it's going to make it to 3 distinct characters. So that's not something that I can take. And I'm gonna skip that and start a new string from B. So then B and then A would make it 2. So that's how I
but
think.
then we can have it's not necessary that you start the next search from B. There's a possibility, there can be a possibility that we get a substring from CEB or something like that. From C also there can be one substring present, right? So it's not necessary that once we have checked for ECE, we have to skip the entire substring.
Yeah.
Because the brute force would be generate all the substrings and then check for this condition, which like all the substrings which has at most 2 distinct characters and find the longest of them. So in case of generating all the substrings, we cannot squeeze our window like that.
Yeah. So do you think that I can start with the brute force and just generate all the substrings and then
how would you generate all the substrings?
I would just generate all the substring using like the substring function of string, and then
But
for
then
each
that doesn't have any constraint. So if you generate all the substrings, you have to generate all the substrings of length 1, length 2, length 3, length 4, like that. So the time will increase.
yeah. So in that case, when I start generating a substring from ECE, yeah, I can only think about then like start with.
Can we use some data structure to store the number of unique characters we are encountering? Can we find a pattern how to eliminate this? Okay, can we focus on the part where we have to find substring, and substrings are continuous characters, right? So will that help me eliminate the characters or the part of substring we do not want to use in our next iteration?
So
Like when we have encountered ECE, if we remove the first E, that still is going to give me one E in the middle. So we cannot take the CEB. It's better to eliminate the last occurrence of E, right?
yeah, this one, right?
Yes. So the if we remove last occurrence of E, we would know that the new substring doesn't contain any characters or the repeating characters from the previous substring.
Yeah, yeah.
Can we think in that direction and
Yeah. So
like some data structure to store the unique characters as well as their last occurrence?
yeah, I mean, we can store that in a map. That I found an E at 0th position, then I found a C at 1st position, then E again. So this would be, so when I find E again, at that time I know that I can basically leave out the first E because I already found it.
Right.
And then I can keep going like this.
Then we found,
a B.
right, but our map size increased, the constraint failed. So which value do you want to eliminate?
Yeah, then we will eliminate the C because that is the smallest, and it would start from E. And yeah, so then C will be eliminated.
So first we'll eliminate, so which one do you want to eliminate, C or E?
I will be eliminating C because EB is like a substring that we can take, right?
Okay.
So I'm going to eliminate C at that point.
Right.
Because C would be, yeah, C is 1, E is 2. So then when I have B, at that time map size becomes more than 2. So I need to eliminate the 1, but then the one to eliminate would be the smallest one that I have, like the smallest index, because then if I eliminate E here, then this is not a substring, like CB is not a
Right.
substring, right? So yeah, I think I can keep going like that and then keep a maximum number.
Right.
Cool. So let me implement
So
that.
what would be the time and space in that case?
Space would be if we can just treat this map as like a constant space because we are only going to keep like 2 entries in the map. So that would be like order of 1 because map is not really growing as the string, and we are going to iterate the string once, so it will be like O of n for the string iteration.
Okay.
So this is like
Sounds
O
about
of n.
right. Can we start coding on this?
Yes.
We were also going to keep pointers, right, Namita?
the pointers to this.
Yes, start and end
I was
whenever you.
I was thinking of just iterating it as like a for loop.
But how will you find the length?
So when I start iterating, at that time I'll keep adding it into the map, and then I'll keep it as a length of that character till the map like a global index is max.
Okay.
I didn't really follow what I'm missing here. So I'm thinking about just going from the first character, start adding it to the map, and then keep the length till I find the another, like if the map is greater than 2, then I don't add it, something like that. Let me try to code it up,
Sure,
and then
sure,
I
please.
can
Sure.
change it. Yeah. Okay. So I'll also figure out how to remove the least index value, but I'm just going to then remove the least index value. Otherwise, you just add it to the map. With that index, and you do max plus plus. No, this is not right. I will have to figure out current length 0. I say current length plus plus. And then this max would be, if like the current length is greater than the max, then I'm just going to
Okay.
take the max here.
Mhm.
So this is how it will keep growing, and if the size is greater than 2, then I'm just going to iterate through the map to figure out what is my least index value. Like basically what was the, if it is E or C that I need to remove, and I'll think about like it later when if I, how do I basically try to optimize it.
Collections.min and map values will give you the minimum character, minimum index.
Oh, okay. Collections dot. I'm not aware of the method.
Collections.min, and in that you pass the map values.
Oh, got it. But
Map
that's
values.
yeah, that's just going to get me a value. I need to figure out
Right.
the key. So then I can
Right.
also have like a reverse map to make it a little better. But
We can just remove the key from map.remove and whatever index we have gotten. So index s dot string dot char add that index, right?
oh yeah, yeah,
So
yeah.
do
Yeah.
not.
Sorry, I'm just
So you need to store that somewhere.
yeah, yeah, yeah.
You can write in and check. I think we are past time now.
Yeah, I think this. I'm just trying to see. So I'm just going through
Here,
the
the
first.
current length is increasing as I is increasing. So here, I
need
am
to
not sure.
basically.
Yeah,
No,
I'm not sure if
I'll
this will work.
this should be like when
Okay.
I'm moving it, I'm basically
But the
resetting the
current
pointer.
length is not, but the current length is not equals to 0. Whenever we are removing any element, you're removing the smallest indexed element. So the current length should not be 0. It
It
should
should
also
be 2
contain.
actually. It should be 2 because then when I'm removing it, that means I'm adding a new one. Actually not even
But
2.
yeah, it's not
Yeah,
necessary that you have 2 elements. You have 2 distinct elements, but
yeah,
they
yeah,
can be,
yeah,
they
yeah,
could
yeah.
have been repeating.
So then in that case, I will have to figure out if I'm at whatever index and I'm
So
removing.
won't keeping 2 pointers, like having a start pointer and end pointer, would help you? Like you keep increasing the end, and then you start and you move the start to that particular character which we just removed. So
Yeah, yeah, yeah.
that would, you know,
Yeah,
give you.
yeah. I think end minus start will going to give me like the length of
Yes.
the current. Yeah.
Uh, so yeah, I think I'm pretty much done, and it was all right.
Yeah. Okay. Thank you so much.
Thank you, Namita.
Yeah.
Thanks, Namita and Minu. So, Namita, how do you think you did in the interview?
Oh, really bad. I think I bombed it. And because I couldn't do the first one, I was like super nervous in the second one as well. And I was just like blanking out.
Actually, both of them were similar questions of sliding window. So the entire point of asking the second question was to follow up the first one, like how well can we do the sliding window?
Yeah.
Okay. Minu, what all feedback do you have to share with Namita?
Yeah, she's able to pick up the hints. The only thing is the coding part. So I think the more you practice, the coding gets better. I think all these small things like collections.min and all of that, we can use it. So apart from that, I think it was pretty great.
Okay, thanks, Minu. So now it's up to the audience feedback. So among the audience, does anyone has any feedback about the interviewer or interviewee? Anything? It's your turn now. You can unmute yourself and start saying.
Yeah, thanks, Namita and Minu. I think one thing was neither the Minu mentioned regarding constraint nor Namita asked, right? Because we get a lot of
Right. So basically, I don't think the interviewer ever tells the constraint part until and unless you ask them about
yeah,
it.
exactly. Because you could have got a lot of hints like, should we go for n square algo or n log n
Right.
algo?
Right. Agreed.
Yeah, that's one thing. And secondly, I think she started writing the code before explaining the approach, right? She could have given a in normal English
And
kind of.
not really. I think we decided on proceeding with the code. She was telling me the pseudocode version, and then when she couldn't think more on that part, we started the coding.
Sure. Yeah, thanks to both of you.
Thanks, Shashank. So more audience, does anyone has any feedback? So I'll just give my feedback. So it was really nice interview. The question was really interesting. The question that Minu gave was really interesting, and Namita was able to give a solution in the beginning, and definitely optimization is a very difficult part. So, but Minu helped a lot in finding the optimization. But yeah, time constraint was there because of which the coding was little difficult.
Right.
But overall, I liked it very much. Both of you did really well. So some more audience, you can tell your feedback. So how did it feel for you? Do you have any feedback for the interviewee or interviewer?
Hey Daniel, thanks for the feedback. Just checking to see if anyone else had any specific feedback. I did take some notes and I was thinking of providing some direct feedback here. So just for context for everybody, right? I tried to break the problem into 4 parts. Usually, there is like a requirement gathering section. That is where you are capturing the requirement, making sure that you're talking about constraints and whatnot. Then you talk about problem solving, where you actually solve what the problem looks like. And then you go down to coding, where you are just like solving the write the code in the way it is. And then the last one is essentially verification, or just making sure that your code works and test it for these items. So I try to capture the feedback in these 4 buckets and try to see how this goes, right? So the interview started at about 4-5 past the hour. I know we had like a little bit of technical things that we were going back and forth. The requirement gathering for the first question, I think it went okay. There was like a good mix of assumptions and a good mix of asking questions and things like that. I think Namita did a good job of. The problem solving did not go well at all. Like we were almost into the 22nd minute of the interview, and we didn't even get to that 2-pointer approach and other parts. So one thing that I think I would have done as an interviewer would be to know that the candidate is very far off at this point of time, and probably would recast the problem as like a 2-array problem, or even like make it as a single array problem around the 10th minute mark. I wouldn't. You did that like much later, so I saw that. But I think I would have done that in the 10th minute, 15th minute mark, because at that point of time, there is no redeeming, right? Once you were like in the 26th minute mark, and then you're like figuring out how to do the one array, left, right, and whatnot. It just becomes a lot harder. From that point of time, there was no, there's no way to redeem the interview or salvage the interview at that point of time. So,
Right.
so I would have been a little bit more brutal with that thing. So that the thing is that as an interviewer, and I'm just kind of mixing feedback for the interviewer and the candidate at the same time. As an interviewer, your goal is to be able to put a check mark next to all the 4 areas. Right now, you have absolutely no data on the testing, because we never got anywhere near that, right?
Right.
So had you helped the candidate with the problem solving itself, you can say 0 on problem solving, but then you could have given, like, could have assessed the testing, the coding and the testing parts of it. And then maybe in a different interview, the candidate can demonstrate problem solving, and they look at this and say, there were 3 interviews, 1 interview problem solving was horrible, 2 interviews it was okay. So you know what, let's hire the person. So you're not collecting all the data points as required as an interviewer. So that would be my recommendation. So for interviewers, the feedback is that you should have specific milestones in mind where a candidate should be transitioning from requirements gathering to problem solving, from problem solving to coding, and from coding to testing. If they are not doing that, it's your job to essentially force them to go through the transition. And if the requirements gathering is not happening, you just would say, make assumptions, move on. If problem solving is not happening, then you simplify the problem or you give them the solution itself, which is kind of what you did, right? With the 2-pointer approach, left, right, and whatnot. And then I would have just gone ahead with that. Now, you did the time check, which was around I think it was like a 32-minute mark or something like that. That message was a little abrupt. So this is more feedback for you, Minu, where if I were you, I would be a little bit more subtle with it. Like, one of the things I would have probably done is to change the entire thing and say, you know what, just implement the 2-pointer approach. We're good. Because from that point of time, we had about 15 minutes. And if the candidate implemented the 2-pointer single array 2-pointer thing, right? And that's more than enough. And that would have been fantastic. I think that would have made it for a better interview. Then jumping on to the second question. So in this question, I was a little surprised because the requirement gathering was actually below average. I didn't think that. I mean, and that's what I felt. Namita, when you have access to the recording, maybe go back and take a look at it. I just felt that you weren't asking enough clarifying questions. And in one case, like the interviewer specifically mentioned about the example, and then you misunderstood the example. So there's a little bit of that. And I think I know why. I think you were a little rattled by the poor performance in the first interview. First question, and then that actually affects your performance and thought process in the second one. So that also goes back to you, Minu, is that your goal is to keep the candidate at their calm positioning. Like, by abruptly switching to the question, right? That does rattle candidates, and they generally do poorer than what they did. Like, the first question was requirement gathering was great, and you notice that in the second question it was not so great, and that is it's the same candidate. It's roughly the same time zone and time as well, right? So what changed was essentially the mindset, and I think that makes a huge difference in this. Now, on the problem solving also was a no-go, because I think 7-8 minutes in, I think brute force was something that you're thinking about, and then you started the coding, and then you started writing some parts of the code. I think the line 87, for example, that you see on the screen, I think Mino helped you with the collections.min, but it's supposed to be map.values, I thought, not value. I think there was just a lot of anxiety and nervousness in the rest of the coding as well. So I don't think it went. This was definitely not one of your best interviews. Now I'm fairly certain, like, you know, a week or two later, you would probably recognize that you would have grown insanely, and then when you look back at this and say, like, was this even me? Primarily because I think this is just like starting off on the wrong foot. It does make this happen. So one of the pieces for the candidate or candidates who are interested in this is that don't let one interview performance affect the next interview. Like, if you completely mess up your interview number 1, then don't let that bleed into your interview number 2, because you have options and opportunities to redeem yourself. And at Amazon, at Facebook, at Google, they do have like 2 or 3 coding interview rounds. And the idea is that if you bomb one, you should be able to, we should be able to collect different data from all of them. And we typically try to take the best of all of these things. So that would be my my feedback. And in this case, of course, we never got anywhere near the verification part of it. Like, the coding was not complete and the verification was also not complete. I think there was one question that somebody asked in the chat, which was like saying, should the candidate always ask about the time complexity first? I don't think that, I don't think we should, like, as candidate, I don't think you'll be talking about time complexity. It will be the interviewer would ask the question about, like, what time complex it is, and that is perfectly fair game. I don't think at any point of time I'm expecting the candidate to ask a question of saying, like, you know, hey, this is n square algorithm. Are you expecting a better algorithm or something? I mean, I just wouldn't. I would just state my algorithm, and I'll let the interviewer tell me if they were actually expecting a better algorithm. Oh, by the way, I particularly like, you know, how you hinted at that particular part where you said, like, it's an n-log n algorithm. You are relying on the fact that the second tree is a binary search tree, so that log n is appropriate, but then you are not relying on the first tree's binary search tree part. So clearly, the fact that the first tree is also a binary search tree, you're missing a trick there, and there is a way for you to use or leverage that fact. I think that was pretty good. But yeah, I think from a question standpoint, the discussions on the chat have been phenomenal. I think people have been enjoying this question. I enjoyed both the questions personally. I have been a little out of touch with these interview questions over the last like 6 months or so. So both of these questions are actually new to me, and I enjoyed having a real live discussion with the rest of the folks as you are going through this. And phenomenal job, Minu, with your questions and the way you guided this. I think there are a few places where you can optimize your interviewing skill to get the maximum data. I think that totally makes sense. And last but not the least, putting yourself in front of like 20 people and having a live coding interview is actually not easy. So extremely deeply appreciated, Namita, for stepping up and volunteering to be a candidate. I think this experience is definitely going to help you become a better candidate, and you'd also be a good interviewer as well in the future. So that's all I had to talk about. I know Elliot, you unmuted. Can you go ahead with your comments?
So essentially this first problem, it really, you need to think, ideally you think about the problem in terms of like layers, and you start them out with the simplest layer. And then if they get that simplest layer, then you've got a data point, and then you can add another layer on top of that. So with this first layer, I'd start out with just 2 sum on a single array. And then if they get, you know, an optimal solution to that, then switch to 2 arrays. And then you can bring in the trees after that and see if they can handle it when they're arrays instead of trees. And that way, when you're like writing your interview feedback, you could be like, okay, they got the 1 array and the 2 array, but they weren't able to get, you know, the optimal solution when I turned it into 2 trees. And so then you've got, it's not just like a pass or fail thing, whereas if you throw like the entire full complexity of it at them up front, then, you know, it's, you know, they sort of either sink or swim, and you don't get as much as granular data, and it can be hard for the candidate that way. And then the other thing I wanted to say was, I wasn't entirely sure how this second problem was related to the first problem. And like generally you want your problems to build on top of each other, like I just described. And then the last thing was that I would write out the question and even write out an example with like, here's the input and the output, and just paste that into the document at the start, and then tell the candidate, you know, you can read this to yourself, you can read it out loud, you can ask me questions about it, whatever they're comfortable with. I found that's a good way to start it. Oh, and the other thing I wanted to say was about the big O thing. In doing these problems, I have found it's helpful to me as I am reasoning about the problem to think about the runtime. Because if I come up with a solution and it's like O of n cubed, like that's probably not that great a solution. You know, maybe I can start thinking about a better solution. And I've been in interviews where I've found the correct solution where I was like, this is O of n squared, but I feel like there should be like an, you know, an n log n solution here. And I just like go through my mind of like different data structures that are like I could use that would give me that better running time. And then I find one that fits. So I think that can be a strategy that can help. That's my input.
Great
Thanks,
feedback,
Elliot.
Elliot. Thanks a lot. And great feedback by Vivek as well. So both of this feedback, I think it would have helped anyone in deciding like how you will be able to interview, or how can you be a candidate in future interviews and all. So it helped a lot, I think. So anybody else, does anyone have any feedback, audience? Okay, I think I'll stop the recording, and after that, okay, I'll stop the recording now.